All right. Here we go. We're going to talk about properties of real numbers. Have a little warm up hanging in here on the screen. We'll probably do that one in class. We'll throw it into Pear Deck. Okay. The next thing we would do is if you want to check with someone in your class, you can, and say, hey, let's zoom this out. I want you to take a look at these examples and counterexamples and see if you can remember all the things that we talked about before. Okay. So remember your natural numbers. So these are your examples. And then these are counterexamples. So sometimes it's better to identify things that it cannot be versus what it is. Other caution that I have for you, natural numbers are also known as counting numbers. So we want to be careful with those. Check out your whole numbers, your integers, your rational numbers, which remember this makes all of these over here irrational. And pi was your best example of that. So think about those, and then we're going to fill those into this chart in just a minute. So pause your video, check them out, and let's see what you come up with. You didn't pause it yet, did you? All right, pause it now. All right, hey, welcome back. So the last set that you had to deal with rational and irrational. We said irrational number is like pi, right? Why is irrational and pi? Why do they go together? Because pi is an irrational number. Is 3.14, yada, yada, yada. It goes on and on and on, right? Do you know what the next number is going to be based on a pattern? No. Just like an irrational person, you really don't know what's going to happen next. Okay, so a rational person, okay, so those are our decimals like 0.35 because they stop. 0.3 repeating is rational because we know what's going to happen next. When you know what's going to happen next, these are rational things. Anytime you have a fraction like 2/3, that is automatically rational. It can be expressed as a fraction, it's rational. So sometimes that's some of the worst things to identify is some of these larger categories. How would you describe someone driving irrationally? Well, a whole bunch of ways. Maybe they're going way too fast. Maybe they're off the road. We're not trying to think about reasons why they would be, but just things that would show that. Maybe they're hitting mailboxes. Maybe they're up on the sidewalk. Maybe they're all over the place. Okay. All right, so that gives an idea of what's happening with our number sets. So the smallest one we had, natural numbers. Okay, so those are also our counting numbers. Okay, so if you had a chance to really work through those examples and counterexamples, the next number set that we have has to do with whole numbers. So I'm going to highlight the O. You guys know why, right? Because that's the 0 that gets added to the counting numbers. It makes whole numbers. We accidentally say whole numbers for almost everything. So just be very, very careful of that. And go ahead and call me out if I do it. Right? The next number set that we have, if we get to something a little bit larger, is we're going to get integers. Okay? So notice we add on those negatives. You know this from Algebra 1. Quick reminder, there are no decimals and no fractions. All right, because in a little bit, I'm going to give you a quick little set there. I want you to try them out in your OneNote notebook, and you're going to find out that maybe you accidentally put something in there. All right, so irrational, that's what we just had. Non-terminating, non-repeating decimals. All right, our examples were pi and square root of 6, things like that. All right, and then we have our rational numbers. Okay, so the big important things, I'm going to highlight out all this because I don't know if you can squeeze it all into your notebook or not. Okay, so if it is a fraction, okay, so if you can write it as a fraction, it's automatically a rational number. The second thing is if it's terminating, that means it stops, or if it repeats as a decimal, it's a rational number. And the very last thing we have is, of course, our real numbers. These are all our rational and irrational. And one thing we'll delve into this year is then talking about the imaginary numbers versus the real numbers. So real numbers become all of these things. And again, we did start from the smallest natural numbers. We worked down to whole numbers, integers, and then we had this kind of double set. Everything falls into rational and irrational after that. And then we get the reals. All right, some of the old properties from Algebra 1 that we sometimes forget about. I'm going to give you a quick little review how I talk about it in Algebra 1. So if you've already had me for Algebra 1, this will sound familiar. What's it mean to commute? Well, you know, if it was your day to come to school, then that's what you did. You said you started at home and you went to school. And what's equal to that is then you went from school and you went home. So that is like A plus B equals B plus A. Boom, there's your commutative property. Okay, so if we're just flipping the order, and this does work for addition and multiplication. What about an association? What's an association? All right, well, there's one of them. They're playing in a bubble right now, and it's called the NBA, the National Basketball Association. I guess there's another one, right? It's a WNBA for the ladies that are balling. We get all that stuff going. And the key here is the association, right? It's a group of people. In this case, it's a group of people who play basketball. So A, B, C, A, B, C. And what I always say is if you are B and your best friend is C, but let's say later on you're still B and your best friend is A, you've changed who you associate closest with. Okay, that becomes the associative property. And this again does work for addition and multiplication. So it gives you some context there. So we'll try and trick you later on, maybe in a little pop quiz in class, something like that. So you want to make sure it's not just about parentheses, it's about making sure who your closest associate is. All right, some other properties that we run into, and just getting these kind of from the textbook closure. If you add A and B, right, you're going to get a real number. Okay, A times B is a real number if you start with real numbers. Okay, commutative property. So here's where we can start to squeeze some things in. So I'm going to zoom in just a little bit as you need to here and jot in the other side of those. Commutative, so that's just B plus A, and that's B times A. No big deal. We just changed our commute. Associative property, A plus B plus C. If it was A and B, now it has to be B and C. A, B, C. So we're going to flip those as well. The identity, you want to keep your identity. So what do you have to add? Yeah, you have to add 0. We're going to add nothing to keep A. What do you have to multiply? 1. The inverse, so this is where you want it to turn into 0. And this is what we use to solve. Okay, so if you were thinking about getting rid of something, right, whether it's by subtracting from an addition or dividing from a multiplication, then that's what happens. And then distributive property, we know this is AB plus AC. We're going to have to distribute this bad boy right in there. Okay, so closure is probably the only real one that's new, but honestly, we don't really use it too much, but I want to make sure you have seen it in case it falls in somewhere. All right, so I said we're going to do a quick quiz here. So here it is. Okay, 0, where does it belong? Well, it belongs in your whole numbers, right? The square root of 19, do you know the square root of 19? If you do off the top of your head, I'm super impressed already because I don't know. That makes it irrational. But notice I don't have a place for those. So it actually goes in to our real numbers because it is still a real number, right? Rational and irrationals make up the real numbers. Pi, there it goes again. Now that we know where to put it, 3.14 and it stops. So that means if it terminates, if it stops, we're going to make that a rational number. Negative 3.8. All right, did I pause long enough? I wanted you to stop and think. This is negative 3.8. It has a decimal, so it cannot be an integer. So be very careful with that. So 4.1, again, it stopped. So we had a string of these rational numbers so we can make sure we think about what's happening. All right, 7 squared is just 49. Can I count the 49? Yeah. 1, 2, 3. I'm not going to do it. All right, you get the idea. If you can count to it, it's counting number. The square root of 9 is 3. So I'm going to squeeze that in as 3. I see a 5. All these things we can count to. 212. Yeah. 10. All right. I hope that's all because that's all I can fit in that little blue box there. Negative 1/2. All right. Negative. So you're thinking integer, but remember it's not because it's a fraction. So negative 1/2. We'll drive that into our rational numbers. Negative 24. Thank goodness we finally got one of them. Negative 24 is a integer, and then 1/4. It's a fraction. Excuse me, it's a fraction, so it automatically becomes a rational number. So now that we dealt with a couple of those square roots, I just want you to think about what's the closest thing to it, right? The closest thing I know here is square root of 49, so that's 7 and 8.8. Well, 7 is less than. Okay, so we don't want to automatically grab calculators when we see a square root. You want to think about what's closest to it. This is close to 25, which would be 5, okay, but it's a little bit under. So that means 5 itself has to be greater than. Okay, so let me circle these so they're a little bit easier to see. All right, so here I'm thinking about the square root of 36 or the square root of 49 to get me 6 versus 7, and I'm still on the closer side to 6. So this one I might have to check, and what happens is it becomes 6.32. So out of everything we've had so far, this might be the only thing I double check on a calculator, but I did that for you. All right, last one, don't let it trick you on this stuff, is the square root of 3 is definitely going to be smaller than regular 3, right? But notice we have negatives. So if you're going to put them on the number line, so here's negative 3, and where would you put negative square root of 3? Negative square root of 3 is definitely going to be on the right. Okay, so that means this has to be greater than. So be careful with the negatives because it flip-flops everything you're thinking about. So take your time with that, and even draw a number line if it helps. See, I did. It helped. Cool, cool. All right, so the next thing you want to do is just a quick check, review what you know, how you know it, and I do have some answers if you scroll down a little bit more on your OneNote page, but kind of guide yourself through here. Make sure you could give an example of those so you know what in the world you're talking about. If you do need to check my answer for it, please come up with your own answer after you realize what it's really asking for. All right, good work. Peace.